Nakajima Ki 84 Hayate. This aircraft had a conventional design but effectively balanced speed, armament, armor, range, maneuverability, and handling. It was the result of Nakajima's fighter aircraft development, led by Chief Engineer Hayate, following previous models like the Ki-27, Ki-43 Hayabusa, and Ki-44 Shoki. Notably, the Ki-84-1 Otsu prototype achieved a top speed of 660 km per hour at 6,000 meters during testing, making it the fastest Japanese fighter used in the war. In post-war American tests at 20,000 feet 6,096 m, it reached 687 km per hour without armament, using 100 octane/140 gray gasoline and American ignition plugs, weighing 7,490 pounds 3,397 kilograms. Designated as a priority production aircraft alongside the Ki-67 Harrier heavy bomber, approximately 3,500 units were produced due to its design that considered mass production factors like adopting standardized manufacturing methods. Despite appearing in the latter half of the Pacific War around mid-1944, it ranked third in terms of production among Japanese military fighter aircraft after the Zero and Ki-43 fighters. The Imperial Japanese Army had high expectations for it as the Greater East Asia decisive battle aircraft, deploying it to frontline combat units, including first-line squadrons, during the late stages of the war. It served on major fronts like China, the Philippines, Burma, and the defense of Japan. Despite earning recognition as the best Japanese fighter from American forces, its overall operational reliability suffered from issues such as the underperformance of the new Ha-45 HAMAR engine, declining fuel and lubricant quality, electrical system problems, and reduced maintenance capabilities at the front lines. Its unique characteristics also required pilots to adapt tactically, making it a divisive asset among late-war Army and Navy aircraft operators. In December 1941, Nakajima received orders to develop a high-performance, versatile fighter aircraft with a top speed over 680 km per hour, armed with two 20mm and two 12.7mm machine guns, suitable for various missions as an evolution of the Ki-44 later called the Type II fighter. Initially, they planned to base it on the Ki-44-3 with a 2,000 horsepower engine, increase wing area for easier landing, extend range with more fuel, and improve speed and climb with a powerful engine. However, as the Ki-84 was meant for Pacific theater operations, they needed to increase its range, leading to a larger wing area and increased weight. The planned weight of around 2,700 kilograms exceeded 3,000 kilograms due to this cycle of adding wing area to address weight concerns. Frontline demands for armor, fire protection, and armament further contributed to weight increase. Despite these challenges, they eventually settled on a design with a larger wing area of 21 square meters, making the weight similar to the aircraft's own weight. The first prototype was completed in March 1943, with a successful maiden flight in April. Despite smooth testing of the initial prototypes, later ones equipped with the production Ha-45 engine faced issues, particularly with the engine and propeller. To expedite practical use and production development, they changed plans and produced over 100 additional prototypes before formal adoption in April 1944 as the Type IV fighter. The Type 4 fighter was designed as a compact and lightweight 2,000 horsepower class fighter aircraft, continuing the design lineage of the Type 1 and Type 2 fighters. It featured typical Nakajima fighter characteristics but had a distinctive design element, a gradually narrowing fuselage shape to reduce turbulent airflow generation. This design aimed to enhance productivity, significantly reducing production time compared to previous models. While the overall aircraft design resembled its predecessors, the Type 4 fighter intentionally had a heavier control system, unlike the lighter systems used in earlier models like the Type 97 and Type 1 fighters. The decision to make the controls heavier was driven by a desire to lower the aircraft's strength requirements, reduce weight, and ultimately improve speed and climb rate. This approach was influenced by the opinion of test pilot Yoshizawa Tsurugi, who believed that heavier controls would lead to better performance. Many pilots highly appreciate older aircraft models like the Type 1 fighter and late-war Type 5 fighter Ki 100 because of their reliability and maneuverability, which allowed pilots to demonstrate their skills. The Type 4 fighter, often referred to as a medium fighter positioned between light and heavy fighters, received similar praise despite being slower than advanced American aircraft and less maneuverable than the Type 1 fighter. Pilots found that by actively using the control stick, the Type 4 fighter exhibited significant turning capabilities for dogfighting, earning it the reputation of a heavy fighter capable of dogfighting that combined the strengths of both light and heavy fighters. Despite its limitations in high-altitude handling, speed, and defense compared to other Japanese aircraft, the Type 4 fighter performed reasonably well in combat against faster American planes and proved effective in ground attacks due to its ability to carry bombs. The aircraft's unique design included a low, downward curved vertical tail, which reduced the adverse effects of propeller wash. This design aimed to minimize the sideways impact of propeller wash on the vertical tail, preventing the nose from deflecting. The Ha-45 engine used in the Type 4 fighter was designed to address Japan's technological engine gap compared to Western nations during World War II. It aimed to provide double the output of the previous Ha-25 engine while maintaining a similar size. The engine's compact design, described as delicate works of art, posed production challenges during the late stages of the war. The Ministry of Munitions integrated Nakajima Aircraft's Tama and Musashino factories to expedite production, but this led to insufficient inspection and many engines not meeting their expected performance. Initially designed for high-quality 100-octane gasoline, the engine was modified to run on 91-octane gasoline with water methanol injection due to supply difficulties. Adjusting this injection system proved difficult and contributed to engine issues. While some argue the Army only had access to 87-octane gasoline, records from operational units consistently mention stable supplies of 91-octane gasoline. To accommodate the powerful Ha-45 engine, there was consideration of replacing the Type 1 fighter and Zero's hydraulic 3-blade propellers with electrically variable pitch 4-blade propellers from Radier, a French company licensed for production by Japan International Aviation. Initially, these propellers were seen as unsuitable for fighters due to slow pitch-changing speeds. Japan International Aviation later developed an improved version called the PE-32 with variable pitch speeds suitable for fighters. However, limited experience with electric variable mechanisms in Japan and the rapid pitch changes led to issues like hunting and engine overspeed. The problem was partially resolved by reducing motor power and slowing the operation speed, but maintenance inexperience and component precision problems caused frequent malfunctions, contributing to the Type 4 fighter's reliability issues. The Type 4 fighter used smaller propeller blades, 3.05 meters compared to foreign 2,000 horsepower fighters, typically 3.6 to 4.0 meters. This smaller size posed challenges in achieving optimal climb and top speed. Some regretted this decision, believing larger propellers would have been better. Nakajima had calculated that a propeller with 76% efficiency could achieve a top speed of 660 km per hour, which the aircraft closely approached. This fighter aircraft was the first in the Japanese Army's single-engine, single-seat fighter category to require the installation of a 20mm machine gun Type 2 5 20mm fixed machine gun from the planning stage. Among the single-engine, single-seat fighter aircraft of the time, it had the most firepower, except for the Type 2 fighter model 2B Ki 44-2B equipped with Ho 301. Additionally, the Type 1 model Ki 84-10 was equipped with the Ho 103 Type 1 12.7mm machine gun, which carried a greater amount of ammunition, with 350 rounds each, compared to other similar nose-mounted guns on aircraft, which typically carried 250 to 270 rounds. However, considering global trends, its armament was somewhat light, leading to the development of Type 2B and Type 3C variants with enhanced armament from the early stages of development. Furthermore, the aiming device was replaced from the conventional Type 100 optical gun sight to the newly developed Type 3 optical gun sight in the production models. This fighter aircraft is equipped with ballistic and fire protection features similar to conventional Army fighters from the early stages. All fuel tanks are covered with self-sealing fire-resistant tanks that have the capability to withstand 12.7mm bullets. Additionally, there is a 13mm thick armored plate behind the pilot seat to protect the pilot's head and upper body, compatible with 12.7mm bullets. Furthermore, the front windshield is reinforced with 70mm thick bulletproof glass. In the event of being hit or crashing, there is an ejection system in the canopy to assist the pilot's escape. By pulling a lever located above the pilot's seat, the canopy can easily detach due to wind pressure, allowing the pilot to quickly exit the aircraft and initiate a parachute descent. The Ki 84 fighter, known as the Hayate, saw significant operational action starting with the Battle of Leyte in late 1944 and remained in use throughout the Pacific War. The 22nd Sentai unit was equipped with production Hayates, which performed effectively at medium and low altitudes, despite its limited high-altitude capabilities. It faced off against the USAF 14th Air Force and quickly gained a reputation as a formidable combat aircraft. Fighter-bomber versions of the Hayate were also put into service, and on April 15, 1945, a group of 11 Hayates launched an attack on U.S. airfields in Okinawa, successfully destroying numerous grounded aircraft. During the last year of World War II, the Ki 84, the Ki 100, a radial engine version of the inline-powered Ki 61, and Kawanishi's N1K2J were the three Japanese fighters that were most effective in countering the newer Allied fighter aircraft. Thank you for watching.